So that is the last talk for today. Now we have Miro speaking about the clean code and how to write a perfect coding in Java.
Thank you, and good evening, everybody. Thank you for being here. Still, last talk of the day. I admire your commitment to learning. My name is Miro Cupak. I'm with a Toronto-based company called Dnastack, where we've built a cloud platform for biomedical data, access, search, and analysis. And if health tech is something that you're interested in or curious about, please come find me after the talk. I do enjoy speaking about it. But this talk is not about the domain. It's about the underlying technology stack, which, of course, is Java. Now, if you saw the agenda, for the conference, you may have noticed that I have a couple of talks here as well as a workshop, and they're all kind of on the same topic, right? They're always about writing clean code in a way, and they're always about new features in the JDK. So when I say new, I mean essentially things that we got in the JDK in the last 2 years or so, basically since Java switched to the 6-month release cycle. So we're looking at Java 9, 10, 11, and 12. So the difference between the talk today and tomorrow is essentially what we're focusing on. Today, we're talking about the language features, and tomorrow, we're talking about APIs and good API design. So if that's something that you're interested in, please come join me tomorrow as well. Now, these are the things that we're going to talk about today. Of course, we're going to cover a local variable type inference, which without a doubt is the biggest language feature that Java got in the last couple of years, so it's certainly worth spending some time on. And that, of course, is Java 10 and Java 11. We're also going to take a look at private methods and interfaces, which is a Java 9 feature, improved try with resources, which is also a Java 9 feature, and switch expressions, which is the Java 12 addition. But before we get to that, I think I should clarify what it means to write clean code. And I think intuitively we kind of all understand what this is about, right? Many of you have probably seen these two cartoons that summarize clean code pretty well. I also like the definition from William Zinsser, who actually has nothing to do with coding. He's an American writer. And he wrote a lot about writing in English, particularly English as a second language. And he came up with these 4 principles for writing well, which is also a title of his book, actually. So the 4 principles are quite applicable to code, too, and they are clarity, simplicity, brevity, and humanity. So in other words, we want our code to be clear, we want it to be simple, we want it to be short, and we want it to be readable by humans. So it's a lot about focusing on the reader, right? It's a well-known fact that we spend more time reading code than we spend writing it, so it makes sense to optimize for that. There are 2 very good books on writing clean code. One of them is actually called Clean Code. That's an older book, but still very much relevant. The other one is called Effective Java, and that one actually just got a new edition 2 years or so ago. So certainly worth checking out. They are very well known, so odds are you have read them before. If not, I would definitely highly recommend doing that. They're probably 2 of the best software development books that I've ever read. And they provided a lot of context and inspiration for this talk as well. So, I like learning through examples, and I'm going to write many of them throughout this talk. And I'm going to write all my examples in JShell, which is Java's implementation of a REPL that we've had since Java, since version 9. If you haven't used JShell before, don't worry about it too much. The tool is extremely easy to figure out, as a tool like this should be. So you will get a pretty good sense for how to use it throughout this talk. Or maybe you've used the REPL in a different technology stack, Groovy, Scala, you name it. It's basically the same thing. So let me just switch to my terminal here, and let's take a look at the first feature, which are private methods in interfaces. So what you're seeing here is JShell. I'm actually running JShell from OpenJDK 12. And I know that this is a big room, so if there are any issues with readability, like font size or anything like that, please do let me know. The vast majority of this talk is taking place in my terminal, so it's important that you guys can read it. Everything good so far? OK, looking good. So since Java 8, the statement that interfaces don't contain implementation logic is no longer true, right? Because Java 8 introduced default methods. And the idea was to allow you to evolve the API without breaking backwards compatibility. So you would provide an implementation directly in the interface, and then everybody who implements this interface would automatically get it, or they can choose to override the method, of course. So here's what that looks like. I'm going to create an interface here. Let's call it my interface. And I'm just going to make it empty. That's enough for now. and I will create a simple class, let's call it my class, that implements my interface. Now, this is a very simple API, right? But imagine your API evolves, and at some point you decide to add a default method to your interface. So I can just go here and create a default method here. Let's say default void default method. And it's going to be very simple. I will just make it print out that the method has been called. So system out print line default method called. Now, of course, if I instantiate the class, I haven't modified the class in any way, I can call the default method here, right? Because it's inherited from the interface. That's sort of standard way of how default methods work. Now imagine your API evolves even more, right? Your default method has grown and is no longer readable. Maybe you want to split it into smaller methods. Or maybe you've added a second default method and they share some core and you would like to extract that to a helper method. If you are in Java 8, there's nothing you can do, right? But starting with Java 9, we have private methods that allow you to do precisely that. So now in Java 9, I can modify my interface here, and I can extract some functionality from my default method into a private method. So let's just call it private method, add a call here, and then actually implement this method. Private void private method. And I think you can guess what the method is going to do. It's going to do the same thing, just print out, then it's been called. Private method called. OK. Now, if I find my class again, I can call the default method. Of course, this works. Calls the private method in the background, right? And if I try to call the private method directly, this will not work at all, right? So the private method is in the interface, but it's not a part of my public API. So it's a very nice sort of little addition to the JDK that allows us to evolve our APIs without polluting them. So to recap some best practices around this, in terms of writing clean code, a good rule is that all your methods should be short, right? And default methods are not an exception. So use private methods to keep them short. Also, don't repeat yourself. Don't duplicate functionality between default methods, extract it to a private method instead. I think one aspect of default methods that's also often forgotten is that even though they were designed for providing functionality in APIs in backward compatible ways, they are not completely safe. And that's important to realize, right? So what default methods are good for is providing default behavior in new APIs that you're creating. What they're not very good for is extending existing APIs, right? Because you don't know how people have implemented or extended your API. And there's no way you can maintain all the possible invariants that people might impose in their code, right? So you can potentially break things for people. So it's just something to be careful about, keep this in mind. So this brings us to the next feature, which is improved try with resources. Now, in Java 6 or before, closing resources, like input streams, output streams, connections, that sort of thing, was quite painful, right? We had to use the try finally construct, which can get complicated pretty quickly, especially if you're juggling multiple resources. Sure, there were finalizers as well, but those are just terrible for closing things, so let's not even bring those up. Then Java 7 was introduced, right? And Java 7 introduced try with resources statement, which suddenly improved the situation quite a lot. So now, as long as you have a resource that implements the auto-closable interface, you can just give it to the try statement directly, and it's going to manage it for you, right? So it's going to be automatically closed when you're done with it. And you can use it pretty universally. Nowadays, pretty much everything in the JDK that implements some sort of a resource that can be closed does implement the auto-closable interface. Anyway, here's how this works. First, in Java 7 style. So let's create a method here, and a method that reads the contents of a file and prints it to standard output. Okay, so we're basically trying to copy a file to standard output. So I'm going to start by creating a method, let's call it readFile, and that's going to take a string referring to my file. And now I'm going to try and implement this. So what do I need to do to actually read a file? Well, I'm going to need an input stream, right? So let's obtain file input stream to my file. And then I need to do sort of standard Java boilerplate. So probably if I want to read from this, I would wrap it in an input stream reader and wrap this in a buffered reader. Let's say like this. And finally, let's store it in a variable for future use. So buffered reader, and let's call this reader. So something like this. Now, what else can we do here? Well, I can now use the try with resources construct, but because I have a reader from before, I cannot reuse it here, right? Try requires a new variable so that it can manage it. So a very common idiom that people use is basically just create a second buffered reader. You often see this being named reader2, and you just do a trig, you assign the existing reader to it, and then you're good to go, right? So now let's try to implement the code for actually copying the file. So I'm going to read it line by line. So what I need at the beginning is the string to store the line. And then while I'm not at the end of the file, I'm going to keep reading it. So while line assign my reader to read line method, and while this is not null, so we're not at the end of the file, and I probably need a bracket here and at the beginning here. So while I'm not at the end of the file, let's just print out the line. System out, print line, line. So something like this should probably do the trick. And I forgot that this can throw an exception, of course. So throws IO exception, just like that. Let's take a look at this. OK, this is looking reasonable. So let's try to use this. And I prepared a file before. Hopefully, it's still there. I can just go to tmp and my hello file. And this works just fine. But you can see that this is not exactly written very cleanly, right? And the unclean part here is, of course, the second buffered reader that I had to create just for the purpose of having it managed by the try construct. That is no longer the case since Java 9. So since Java 9, what's supported here are final variables as well as effectively final variables. Effectively final means that it's a variable that's not explicitly defined as a final, but it just doesn't change after you initialize it. So what that means is that I can just modify my code here, and I can completely get rid of the second reader now. I'm just going to remove it here and rename this to reader. And if I try to run the read file method, this still works. OK? So just a tiny little addition to the API that allows us to clean up our code a little bit. By the way, there is another little feature added in Java 9 that allows me to simplify this particular code even more. In our code, what we're doing, we're essentially just copying a file from an input stream to an output stream, right? And it turns out that input stream now has a convenience method to do exactly that, and that method is called transfer2. So I could actually replace all of this code just by doing something like file input stream to my file, tmp hello, and I can just transfer to system out, and that does the same thing, right? So significant simplification here, just a little bit nicer. So let's recap some best practices around this. Basically, always prefer the try with resources construct, right? Don't use try finally anymore, and certainly don't use finalizers to do these things. Be aware of convenience methods in other APIs that deal with I/O that can simplify your things, such as the input stream transfer2 method. And don't create unnecessary helper objects. So remember, you can now use final and effectively final variables directly in your try construct, so no need to create all these extra objects that we used to do. So that was Java 9. Let's jump to Java 12 and one feature that they introduced, which is called switch expressions. Switch expressions is not actually even a full feature. It's something that's called a preview feature. And just out of curiosity, who here knows what preview features are in Java? OK, basically no one. So preview features are essentially like a staging environment for language and VM features in Java. So it is a way for the JDK developers to give you access to some stuff that you can use. But the stuff is no longer finalized. There are no requirements on backward compatibility. It might disappear. Hopefully, it will be promoted to a full feature in the JDK, but it might change in backward incompatible ways. In a way, this is similar to incubator modules. So preview features are to language features and VM features, what incubator modules are to APIs, right? Don't worry, these things are not available by default. You have to pass a special flag to the launcher or the compiler if you want to access this. Otherwise, things would break. And in fact, we can see that flag here. If I go to back to my JShell and take a look at the environment, it's the enable preview flag. So switch expressions are a preview feature, and now I'm actually allowed to use it here. Switch expressions are essentially an extension of the switch statement that also allows it to function as an expression. So this also solves two kind of, I wouldn't say bugs, but slightly annoying aspects of switch, right? The default scoping of switch blocks, the block is treated as a single scope, and the default control flow behavior. So the fact that things sort of fall through and you need to use breaks, right? This is basically done by introducing switch labels that kind of resemble lambdas. So I can just initialize a variable here that I'm going to use in my switch, and I can then use switch on this variable and implement a couple of cases. So let's say if this is 0, just return 0. Otherwise, return 1. And this works. And there are a couple of interesting things about it, right? First of all, you can see that this returns 0. So it returns the value from the first branch without using any breaks, right? Second of all, we're only using expressions inside the branches, not statement. And finally, this whole thing is an expression, right? This has a return value. In this case, is 0. So that's very nice. There's also a convenience aspect to it. The syntax is very concise. It's very readable. And it's kind of flexible as well. I can, for example, aggregate multiple cases here. So I could say, OK, if this is 0 or 1, return 0. Otherwise, return 1. So kind of a nice simplification here. We can also still use this concise syntax with statements. Let me just simplify this so that I don't have to type as much. I'm just going to keep one branch here. And I can replace this with a statement. I can do something like this, print line, my variable. And you can see that now the value is printed out, but there is no return value, right? So now this works as a statement. We can also do the trick that we do with lambdas. So if you want to execute a couple of statements, but still keep it an expression, still keep a return value, you can wrap them in a block. So we can do things like, OK, wrap this in a block, and then I can use the break statement to return a value, just like this. So you can see that now the statement was executed, it prints something out, but it also has a return value. So I just wanted to use this example to point out that the break statement was also extended to accept the value now. So essentially, it kind of functions as a return for non-void functions. So that's pretty cool. So let's recap what we have here. So remember that switch expressions are a preview feature, right? So most likely not a good idea to use in a serious production system. It's an extension of the switch statement, so that it can be used as either a statement or an expression. Both forms are available. And both forms can use the traditional as well as the simplified scoping and control flow behavior. So a good rule of thumb is to prefer the simplified form. Now that we're used to lambdas, this feels very natural and very readable. There's also a convenience aspect to it. The syntax is very concise, and we can aggregate multiple cases. The cases of a switch expression are exhaustive. They must be exhaustive. In other words, what that means is that you have to use the default clause unless you're dealing with an enum and you've exhausted all the possible options in an enum. In that case, the compiler can actually insert the default branch for you. The break statement has also been extended to take an argument, which becomes the value of the enclosing switch expression. And one final thing to note is that switch expressions are similar to lambdas in a way that they're also poly expressions. What that means is that if the target type of the such expression is known, it's pushed down to each branch of the switch, and the type of the switch expression is the target type. If the target type is not known, a new type is computed based on what you have in all the branches. So this creates some very interesting things for type inference. Speaking of type inference, this is, like I said, certainly the most interesting language feature in the Java language that affects every one of us, right? And as is typical with Java features, this is not a new revolutionary concept, right? Java tends to be very conservative when it comes to adoption of new things, and this is not an exception. This is something that has been available in other languages for quite a while. You might have seen it in C# or in Scala. And starting with Java 10, we have it in Java as well. In fact, the local variable type inference that we have in Java is still very limited. Basically what it does is whenever you have a variable declaration with an assignment on the right side, all it does is it takes a look at the initializer and it infers the type on the left based on the type of the initializer. That's really all there is to it. So what this means in practice is that starting with Java 10, I can declare variables using the var keyword. Actually, calling it a keyword is not correct. It's not a keyword. It's something called reserved type name, but you get the idea, and we'll see what that means later. So I can create a variable like this, and if we take a look at this variable, you can see that it's actually stored as a string. So this was correctly inferred as a string, right? We're not getting rid of static types or anything like that. We're just inferring based on the surrounding context. This is a string and will always be a string. So if you're seeing this for the first time, you might be thinking, this seems a bit sketchy, right? There's probably some case of polymorphism that I can construct that would allow me to break things in weird ways. And that's actually right, which is why there's a very specific set of rules that you need to obey when you want to use this. And that creates confusion for the reader, and it's a clear sign of unclean code. So let's examine these situations that might seem confusing. Situation number one are declarations without explicit initialization, right? If I just do something like this, it turns out that this actually doesn't work. And it should be noted that this is purely a design decision, right? This could have worked. The compiler sees all of our source code, so if we don't initialize it here, it could easily go further down our source code, determine what the right type should be, and just infer it. It was purely a design decision not to do that. They basically just decided that they want to, avoid this type of action at a distance inference errors, so this is not supported. We have a similar case if we try to initialize it with something like null. This also doesn't work. And it might seem obvious, after seeing the previous case, but I think it's worth noting that even if we don't want to infer the actual type as a performance optimization or whatever, there are still other things that we could have done here, right? For example, we know that this is a null, so we could have just inferred a null type. A null type is a very special type in Java, right? It's the only type that's a subtype of every reference type. What also makes it special is that null is its only value, right? So we could infer it here, but then wouldn't be very useful. Like, we would never be able to reassign the variable because null is the only possible value there. So that's not very helpful for us. So how about we go on the other side, right? How about we try to go the most general route and we try to infer the most general thing possible, which would be an object. Of course, we can do that as well, but that wouldn't be very pragmatic, would it? If I infer this as an object and later I assign a string into it, I would expect that string to behave like a string, so I expect to be able to call all the string methods on it. But that wouldn't be the case. I would have to cast it everywhere, which just wouldn't be very practical. So essentially, we ran out of options. There's nothing good that we can infer here, so we're just not going to allow that. It should be noted that this is purely a matter of not telling it the type on this line. There's nothing like inherently weird with null. For example, if I tell it that specifically I mean that this is an integer null, this is going to work just fine, right? So things like this can be a little bit confusing when you're reading this for the first time. We have an interesting situation with compound declarations as well. If I try to do something like this and initialize multiple variables on the same line, which of course is valid Java code, it doesn't work with var. And again, this is just a design decision. It was essentially deemed too confusing, and of course they're trying to encourage people not to do that, so it's just not allowed. It also doesn't work in methods or classes. If I create a very simple method here, let's say I'm just going to create a method called increment, which takes an integer and returns integer plus 1. If I try to use var in place of an argument of the method, this will not work. Var is not allowed there. If I try to use it as a return value, also not allowed there, right? So it doesn't work anywhere in method signatures, which kind of makes sense if you think about it, right? When you're thinking of method signatures, you're essentially defining your APIs. You probably don't want to have vars in your APIs, especially in the case of an argument, right? That's where you're dealing with overloading, so it kind of makes sense not to rely on type inference there. There's a similar situation in a class case. If I create a new class and just have like a class level attribute there, I'm going to use var, initialize it correctly and everything. This still doesn't work. Var still not allowed there. And the reason is essentially this is meant for local variables. This is meant for variables with very limited scope. So they just specifically decided not to allow it at the class level. It also doesn't quite work when you're dealing with try and catch, specifically the catch block. If I use var here in place of an exception, this is not going to compile, right? Also, if you think about it, it kind of makes sense, right? With exceptions, you want to be very specific when it comes to error handling, basically. And since all the exceptions inherit from the same class anyway, you want to be extra careful when it comes to inference. You don't want to accidentally end up inferring some sort of a parent and then having a wrong error. Things get even trickier when it comes to arrays. I can, for example, use var in place of an element of an array. So maybe just something like this, and initialize it with something. And you might be surprised that this actually doesn't work, right? And it tells you you just cannot use it as an element type of an array. So a natural question now is, OK, not as an element. How about I use it as the whole array? And it turns out this also doesn't work. And it actually gives you quite an interesting message. It tells you array initializer needs an explicit target type. And this might sound weird when you see it for the first time, but it's actually a very accurate description of what's going on. If you think about it, when we take a look at this array, we don't actually know what type that is, right? We don't know if these are shorts, bytes, or integers. This can be anything. So actually what's happening with arrays is the right side is trying to infer the type from the left side. But now we've added another layer of type inference where the left side is trying to infer from the right side. So you have kind of these conflicting type inferences going on, which is why this case is just not allowed. However, if I try to initialize this array differently, maybe by using something like this, it turns out this actually works. So it's not the case that it just doesn't work with arrays. You just have to initialize it the right way, right? So in this case, of course, I'm fixing the error from before because I'm explicitly telling it that the target type is an int. So a little bit of a tricky situation, especially if you're trying to refactor and replace things with var. Things are tricky when it comes to primitive types as well. Of course, this is a valid Java code, but if I try to replace this short with var, it's going to work, but taking a look at this x, it's actually inferred as an integer, right? Not as a short. So that's also kind of a tricky thing to keep in mind. There are several primitive types that all infer to the same thing, and then thing is an int. Where things get really tricky are lambdas. So let me define a quick lambda here. I'm just going to create a consumer, and it's going to take something and just print it out. Something like this. And this, of course, is valid Java code. But if I try to replace this with var, I'm not going to be very successful, right? And it gives me an interesting error message, something that might seem familiar right now. Lambda expressions need an explicit target type, right? We've seen this before with arrays. And that's the exact same problem that we have here. Essentially, just by looking at the lambda, you don't know what the type should be. So there's already a type inference from the right side to the left. And now we've added another one, so we just cannot allow both, which is why this doesn't work. The situation would be the same if we made this a method reference, of course. Method references are just lambdas, right? If I try to do something like this, this works, but replacing the consumer with var will prevent it from working. It's interesting what happens if you try and introduce var to lambda parameters. If I, for example, took this implicit parameter and just added var here, and of course I want to have a consumer here so that this doesn't fail, it turns out that this actually works. And this might seem like it's obvious, but this actually only works in Java 11 and upwards. This would not work if we were running Java 10. So this is an extension to type inference that was added in release 11, right? They basically saw, OK, so we can use var pretty much everywhere with local variables. For consistency, it makes sense so that we can use it with lambdas as well. So now this is allowed. It gets a little bit tricky when you have more of these things. So if I change this to be a bind consumer and add another variable, maybe something like this of course is fine. But if I try to keep one of these arguments implicit and use var for the other one, this will not work. And it tells you you cannot mix var with implicitly typed parameters. OK, so it's telling me I cannot use it with implicitly typed parameters. How about explicitly typed parameters, right? How about I do this? Well, turns out this doesn't work either. Cannot use with explicit type parameters as well. So basically, once you decide to use var, you cannot mix it with anything else. That's what this comes down to. Another fun thing to look at is naming, right? We now have this new identifier in our code. We now have var, which wasn't there before. So a natural question to ask is, can I still name things var? In other words, can I, for example, name a variable var? Can I do this? And it turns out that you can. I certainly would not recommend doing that, because from readability perspective, this is obviously not good, but it is fully possible. And this is why it matters that var is not a keyword, but it's a reserved type name. If var was a keyword, this would not work, right? But because it's a reserved type name, this works just fine. In fact, I can use it with methods as well. If I created the method just like this would also work. If I created a class that's also called var for whatever reason, now things break, right? Because remember, it's a reserved type name. So you cannot use it with types. Everything else, fair game. So this is the tricky thing here. And it actually tells you that, OK, this is a breaking change as of release 10. But if you name your class var, you're basically breaking so many naming conventions already that we've just kind of accepted this as like a sacrifice that we can make. So yeah, that's how this works. So let's take a look at something even more complex than this. Let's take a look at generics, OK? So I'm going to create a list, make it an array list, and let's say array list of string. And this, of course, is going to work, right? This is, in fact, one of the cases that this feature was specifically designed for. Types can get very complex when you're dealing with generics, so this just makes sense. If we take a look at the type of this list, what this got inferred to, you can see that it's correctly an array list of string. But one important thing to note here, right? This is not how you would write this. If you were writing this manually from scratch, you would make this a list. You would make this an interface. You would make it an array list. That's not how type inference works. Type inference always infers the most specific type, right? So that's something to keep in mind. Don't just upgrade to Java 10 and then change everything to var, because it can potentially break your code. For example, if I was relying on this being a more general implementation of a list, and later I assigned a different implementation of a list into it, now this would break. So it should be noted that you're very unlikely to hit this case, just because the feature was designed for local variables with very limited scope. So it's actually quite unlikely that you would reassign a different implementation into it. And if you do, things break within like the 3 lines of where you are in your code base. But it is something to keep in mind. What you might find very surprising, though, is that this keeps working even if I remove the type. Even if I just keep the diamond operator here, this is going to go through, right? And this is interesting. This was probably, out of all the cases I've tried, this is the most confusing one to me. If we take a look at this list, it's actually inferred as an array list of object. And the strange thing about this is that we have so many seemingly arbitrary rules around type inference already, where clearly they put these rules in place to prevent us from creating something that's not very useful to us. But in this case, we're getting a data structure that's not useful at all. Array list of object is almost never what you want, right? So it's a tricky question, why is something like this allowed? And I don't actually have a good answer for this, but I can hypothesize. I would imagine they basically introduced this for consistency reasons, right? The diamond operator was available in Java prior to local variable type inference. And there were already cases when you could end up with an object, right? That's just how the diamond operator works. So then after they introduced local variable type inference, for consistency, they kind of had to keep telling the same story, right? So I think that's why this is allowed. So maybe if both features were introduced in the same release of the platform, this would be different. Maybe this wouldn't work, but I guess we'll never know. An interesting thing here is that if I actually keep the diamond operator but pre-initialize this list with something of a known type, maybe like an integer, and then take a look at the type of this list, this will actually infer correctly. So it is smart enough to look inside the arguments of the constructor and determine the type, right? So now we're getting into really extreme cases, right? And one of these really extreme cases are capture variables. Capture variables, maybe you don't know the term, but you've certainly seen this around. It's the thing where we use question mark to denote the type, right? So essentially wildcards, or in particular collections of unknowns, are relatively common. So I can, for example, create a list of unknown. Let's call it a list. And I'm going to initialize it with something, let's say an integer. Now, if I take a look at this list, here, you can see that it's exactly what I typed, right? It's a list of unknown. But now the tricky thing is that if I try to extract an element from this list, which clearly it is there, I can see that one is there, this works without problems, correctly extracted one. But if I try to add it back to my list without transforming it in any way, it actually fails. And it tells me that object cannot be converted to a capture. So that's pretty strange, right? And the reason why this doesn't work is actually the type of the thing that I extracted. So the problem is not with the insertion, the problem is with the extraction here. It turns out this actually got inferred as an object. So of course, in the next step, when I try to add an object to a list of something that's potentially more specific than an object, of course this doesn't go through, right? So there is a sort of a special rule for local variable type inference when it comes to capture variables. Essentially, they always get projected to their supertypes, which most often is going to be an object. So just something to keep in mind here. Another kind of tricky thing here are anonymous classes. One thing that's really known about Java is that they don't have an implementation of a pair or a tuple, right? So we can just create one ourselves. And I can just, a very easy way of doing that is just using an object, right? And I try to create an anonymous class based on my object, and essentially just extend it with a couple of attributes. Maybe something like this, and let's put in another attribute, just like that. So this is a completely valid anonymous class, right, representing a tuple. Now, the question is, can I actually access something here? And the answer is yes, of course, no problem here. And this seems like it's not a big deal, right? But it actually turns out this is a very, very big deal, because this would not work prior to Java 10. That's why you've never seen an implementation of a tuple done this way, right? It only works with type inference. And the reason is it only works in type inference, again, lies in the type of the thing that was inferred. So if we take a look here, it's something really weird. It's an anonymous class extending an object, right? Anonymous classes belong to a group of types that are called non-denotable types. They are basically types that you cannot name. So they are supported by the compiler, but they're not exposed to the user. But var actually exposes these types to us. So what's happening here is that I was able to infer something more specific than an object, right? Whereas if I was in a previous release of the platform, I would have to name the class here. But anonymous classes are non-denotable. There's nothing to name it with. The only option I have here is an object. And then, of course, if I try to access this, this doesn't exist. This is just a regular object, right? An object doesn't have an attribute called A. But with local variable type inference, I was able to infer something more specific that's aware of these extra attributes. So it's a very nice trick that you can certainly take advantage of. But again, it's one of those things, just don't use it for readability reasons, right? If somebody was trying to understand your code, they basically have to be aware of this specific trick to be able to understand what's going on. And still, we're at the point where this is not super well known. I'm going to show one final thing here, just to tie it back to switch expressions that we've seen before. So let me just find my switch from before. Maybe a simpler one, maybe something like this. Oh, and I need to reinitialize my variable. It's a different type now. So this is my switch, right? And we know that it's an expression. We know that it returns a value. So naturally, I can use it in combination with type inference, and I can do something like this, right? And this, of course, works. If we take a look at this variable, it's actually inferred as an integer. So nothing too surprising here. Except this switch statement is not the method, right? Like we've never committed to a specific return type. Nothing prevents me from doing this, right? Nothing prevents me from returning different types in different branches. But it turns out that this still actually works, right? This is still 0, even though I've done these different types here. But if we take a look at this variable, there are a couple of options what you can expect here. It can be an int, or it can be an object, right? It turns out it's actually something completely different, something a lot more complex. And this is a little bit hard to read because of how small my terminal is, and there's a lot of things going on here. But essentially what's happening here is I have an intersection type combining 4 different interfaces. And some of them are parameterized, which makes the line even longer. But I have a serializable here, a comparable, a constable, and constant desk. And you're probably thinking, OK, serializable, comparable, I know those, right? Maybe you don't know the remaining 2. And that's completely fine. Those are part of the JVM constants API, which was also introduced in Java 12. But that's completely out of scope for this talk. So basically, what's happening here is the same situation we had with anonymous classes, right? It was able to infer a non-denotable type that's more specific than an object. Essentially, it found the parent of string and integer, which is a combination of these 4 interfaces. This is what they have in common. So that's pretty interesting, right? So let's just recap some of the best practices around using local variable type inference. Well, keep in mind, we're not getting rid of static typing here, which is pretty universally recognized as a good feature of Java. We're merely inferring. If you don't have experience with a language that has had that feature, you might feel like this feature actually reduces readability, and that's completely fair. In fact, that's how many people, including myself, felt when lambdas were first introduced. For quite a while, after lambdas were available, I was writing lambdas, but I was specifying the explicit type everywhere because I just felt that the type information actually improved readability. But then after a while, I got used to lambdas, and I suddenly realized that the shorter form is actually more readable. So I think it's going to be the same case with this. You might not be completely on board right now if this is the first time you're seeing this, but I think it's going to be one of those things where you get used to it, and then it's going to make sense. This feature reduces boilerplate and improves readability. So it basically reduces clutter and lets more important information stand out. It's particularly useful when you're dealing with generics and types further parameterized with generic types. Basically, whenever the type information is really complex, because it allows you to shorten it to just 3 characters, right? In a very simple case, just imagine iterating through something like an entry set of a map that uses some complex types. It's also not only about readability. This helps with maintenance and refactoring as well, right? For example, let's say I have some domain class and I replace it with another class. Normally, when I refactor, I would have to rename all the occurrences of this class in my code as well. But if you're using var, those just get inferred automatically, right? So refactoring is much simpler with this. This works well with local variables, with initializers, and for loops, including for each. So certainly a good idea to use it there. Use it when you're initializing the variable with a static factory method or a constructor. So something that has a name that already tells you what this is about, right? For example, the name of the constructor is by definition equal to the name of the class. So it doesn't make sense to have that type information on both sides. So just use var on the left. It's a great tool for substituting complex types, particularly containers like collections or optionals, especially when used with generics. It's also really good when you're trying to break sort of long pipelines or chains of code. Like sometimes people put streams chained onto other streams, and they don't break them apart. They just keep one long pipeline, because the intermediate types that you would end up with after breaking it would be super complex, and it actually would be really hard to read. So it's just easier to keep it as a single long pipeline. Well, you don't have that excuse anymore, right? Now you can break it apart and just use var, and it's going to work very nicely. Note that this doesn't work with a bunch of constructs. It doesn't work with methods, constructors, method return types, fields, catch, or any other kind of variable declaration. So it's pretty limited. Particularly note that this doesn't work for method signatures, right? You don't want to have var in your API. You want to enforce the contract there. Keep in mind that it's not a silver bullet. It works for common use cases, and it's good. But sometimes having an explicit type can help readability. So just evaluate it on a case-by-case basis, essentially. It's particularly the case when the type isn't obvious from the expression that generates it. Be careful when using this with primitive types. They might not infer to what you expect them to. And remember that the program to the interface rule doesn't work with type inference anymore, right? So that's a common idiom in Java, is to construct an instance of a concrete type, but assign it to the variable of the interface type, which is a good pattern, right? Because it binds your code to the abstraction rather than the implementation. So it's good for maintainability in the future. You're basically not creating a dependency on a concrete implementation. This, of course, does not work with type inference. Type inference always infers the concrete type, not the interface type. But in this case, it's generally considered acceptable. It wouldn't be OK, probably, if we were doing this for fields or methods. But because it only works for local variables and variables with very small scope, even if something breaks, it only affects the surrounding few lines. So it's kind of a compromise that we're generally willing to accept. And we're not only sacrificing flexibility, right? We're also gaining some flexibility in terms of refactoring, like we mentioned. Be very careful about combining type inference with the diamond operator or generic methods, because things can get pretty weird, right? Remember the array list example. The problem essentially is that the inferred type can change with arguments that you give on the right side. So if somebody is maintaining your code and it's just removing an argument, things can break all over the place because the types change. So just be very careful about that. And also be extremely careful when using this with non-denotable types, right? It works for intersection types. It works for capture variables with the specific rule. And use it very carefully when you're using this with anonymous classes. Just remember the example where we had an attribute in an object. Pay attention to naming. Having variable names that provide useful information is now more important than ever because of the absence of types, right? When you're naming a variable, just really think about it. And in particular, don't use var as part of variable names, even though you can with methods as well. Avoid Hungarian notation. You might be tempted to encode the type name in the name of the variable, now that we don't have types, essentially. There's still no place for it. Just leave that to the compiler. Don't rely on IDEs, right? Every IDE has a feature where it can show you what the inferred type is, but it often involves a keyboard shortcut, so it's not just visible if you're reading the code. And then, of course, people read code in other places. People read code on GitHub all the time, right? So keep that in mind. Don't just rely on the type information. Rather, use a very explicit name. A very good pattern for writing clean code is minimizing the scope of local variables, right? That increases readability, increases maintainability of your code, reduces the likelihood of error. And one technique for doing that is declaring the variable when it's first used, right? Because otherwise, it just distracts the reader. In fact, if you can't use var because you don't have an initializer, it might be a sign that you're trying to use it too early. So it might be an indicator of bad design. So just think about it. Almost every local variable declaration should contain an initializer. There are very few exceptions. One notable one is if you're trying to use it with try and catch and finally construct, right? Sometimes you need the variable from the try block to use it afterwards. In that case, of course, it's valid to extract it before, but that's one of the few exceptions. A related fact is that you should prefer for loops to while loops in terms of cleanliness of your code, because for loops allow you to keep the scope of the variables minimal, right? You can just define them within the scope of that for loop. Also, var is particularly usable for loops, both traditional and enhanced for each. Keep your methods small and focused. If your method does more than one thing, you might have local variables that are related to one activity to kind of get in the scope of the other activity, and you might end up reassigning things of different types. Of course, this doesn't work with var, and can be a sign that maybe your code could use better design. So yeah, that's it from me. If you have any questions, we're basically out of time, but I'll be around after the talk, so just come up and say hi. And otherwise, if you want to know what else is new in Java and how you can write clean APIs, come join me tomorrow. I think it's 12:20 in this same room. And otherwise, thank you, and enjoy the rest of the conference.
Any questions? So it seems to be there are no questions. Thank you very much.